Okay, so I've had a look at this question and I've drawn in some of the vectors that we can actually work with now in a minute, okay? But when you see this here, okay, these are all vectors, they bolded, okay? So they want us to actually work out what they are, right? So what is AC, for instance, okay, as a vector. Now, when we write it down, we're going to write it down like that, right? AC with an arrow above it to show we're going from A to C. And if you think about it, going from A to C is the same as going from A to B, okay, and then going along further along the journey from B to C, okay. So you can think of the journey from A to C as two journeys if you want, going from A to B to start with and then B to C, okay. And we know, don't we, we know A to B is little b, okay. It's kind of bolded line here, that vector, and they tell us in the question as well, yeah, it's up there and I've written them here. So we know that's little b, but you know what, BC, it's actually going to be the same vector, isn't it, if you think about it, because not only is it going in the same direction, and we need to appreciate that, it's obviously it's going in the same direction because it's part of the square and it's vertical, just like this is vertical, it's going in the same direction, but it's also the same size, isn't it? Okay, so if you want, you can put little b there as well if you want to. It's the same size because it's the same length. Remember, the length represents the size of that vector. They're the same. So it's just another b, isn't it? So essentially AC is just 2b, okay, doubling b. So with b then, okay, BE, well, where are we for BE? Well, BE is there, isn't it? That vector there, so drawing the arrow in, beat E, well, that there is going horizontally, okay, and you've got to look at where it's parallel to it, and of course it's parallel to AD. So actually we could say, look, BE is just equal to that vector AD, okay. Vectors can be equal, they don't have to be in the same place, okay, right? You can put vectors in different places and they can be equal because they have the same effect. They take you from one place to another, they've got the same displacement relative to the starting position, okay, and it is in this case it's parallel, it's going the same direction and the same size. So we could say BE is equal to little d, okay. C then, HG, right? Well, let's have a look at what HG is. Well, HG is that there, okay, and again HG is the same as BC, little b, it's the same as AB, so we can just say straight away little b. What have we got next? DF, okay, well DF takes me from here to here, and again it's very much like AC, isn't it? It's parallel to AC and the same length as AC, so we can say, look, DF is equal to AC, which is equal to 2b as we worked out in question A there. So where are we next then? We're on to E, okay, AE. Now AE is kind of interesting because it's that diagonal vector, isn't it, which I've drawn in. I drew that in myself, going from A to E. Now we need to think, okay, to get from A to E, what is that? Well, we can think of A to E, that displacement. You can do it alternatively, you can look at the fact that you could go across here and then there, okay. Even though this is sort of a longer route, you end up at the same place, yeah, and that's what vectors are all about, okay. You can find equivalent ways of getting there, okay. Doesn't matter if it's longer. With vectors, we're just interested in the result, the outcome, okay, the overall effect, and we end up at E in both cases, don't we? So with AE, I've written this here, okay. AE is the same as going A to D plus D to E, so across there, which is little d, so across there little d, and then up here, which is of course the same as that one there, which is little b. So there's your answer there, D plus B, okay. So with F then, DH, okay, so DH, well, DH, if you notice, that diagonal there is the same as that diagonal there. So DH is the same as AE. Okay. So you can just say it's the same as that one, D plus B. Okay. Exactly the same. So then the next one, HB. Okay, HB. Now HB is interesting because we're going horizontally. Okay. we're going twice the sort of length of AD here, so it's going to have D involved, but it's going to be twice it. But you're going backwards, aren't you? HB is backwards, so it is that vector, but the reverse of it and double it. So we're going to say HB, okay, in effect is double AD, but the reverse process, you could say minus 2AD, so minus 2D, okay. So hopefully you can see what I'm doing there. You know, this here is little d, isn't it? This here is little d. So B to H will be 2D, but if you go in the other way, HB, it would be minus 2D. Okay, so let's work out the other ones a bit quicker now. HFE, so FE is that one going from F to E here, so that will be minus B. Yeah, so we minus B there. Okay, AH, going from A to H. A to H is the same as going across here, 2D, and then up here, B, so 2D plus B. BI, so B to I, that's the same as going across here, 2D, and then going this way, which is the reverse of B, so 2D minus B. EI, so E to I, so that'll be D minus B. And finally then FB, well there's F, there's B, so F you've got to go down here, which is minus of that, yeah, so minus B, and then you've got to go this way, so be minus of that, so minus D minus B.